Hello, everyone. Welcome to our session. Could you hear me?
Yes, we can.
Oh, thanks. Thank you very much. And today is the session of our Fair Digital Object Fabric industry strip. And the name of our session is A Fabric for Fair Digital Objects. Here's the agenda of this session. And at first, I forgot to introduce myself. My name is Xin Chen from Computer Network and Information Center, Chinese Academy of Sciences. And you can also call me Laurie. And at the beginning, I will give a small, short introduction of our interest group and our new co-chairs. And then we will have a high-level view of the FDO framework. And then we will have two use cases, one from China, Asia, and one from Europe. And then we will have some discussion. And at the bottom of the screen, on the screen, you can see the collaborative notes. And I also put the links in the chat box. Please sign in, write down your name. And you can also write down some comments or any other problems in the questions in the collaborative notes or also in the chat box. And a minute. So at first, maybe I think there are some newcomers in this session, and maybe there are also some newcomers in the following. Maybe they will watch the recording online. So I think I have to introduce something about our group. And in 2013, our interest group was originally founded, and at that time it's called Data Fabric. And we have some we are concerned with cross-discipline infrastructure and how to solve the challenges. And last year, many people are confused about the name, so we changed our name from Data Fabric to Fair Digital Object Fabric. And now we are aiming to promote the creation of the ecosystem of fair digital objects. And we are also in RDA, we are also a communication and coordination platform. We hope to creating international consensus about the specification of fair digital objects and the option model of fair digital objects. So, and we also trying to exchange implementation details. And here's the charter of our interest group, so you can you can get some more information from the link. And now I want to introduce a new chair of our group. We used to have 3 co-chairs of this group, and now we have a new co-chair, Maggie Hellstrom, but it's very sorry. Rana, Robert, and Maggie, they couldn't manage to be here today. But here's a short introduction. Introduction about Maggie. And now Maggie is also trying to organize a training about fair digital objects. So if you have any interest, you can find something at the collaborative notes. You can write down your needs, or if you have some existing material to share, you can also give some clue and write down them in the collaborative notes. So now we will have some the next agenda, or we'll have Ulrich to share about components and services in the FDO framework. But let me see whether he's already be here. Oh, he's here. Sorry, please wait a minute, because at the beginning I didn't saw Rich, so I changed the sequence of the slides, so I will get it in the right sequences. Okay.
All right, we see you, but we don't hear you. You're still muted. There you go.
Yes, so for some reasons I was muted again. But now you can hear me probably, and you can see my screen, correct? Okay.
Oh, sorry. And you can hear me now?
Yes.
Sorry. So I will hand it to you, Rich.
So I'll start.
Yes.
Yes, thank you for letting me here and talk about the components and services in an FDO framework. First, let's see. A short overview of the content. First, I'll start with a message from FAIR principles. Then I'll go, because this is part of what is said there, into types and attributes, registries for them, profiles, and at the end, I'll come to a closer view of how to implement all these services, and of course, questions at the end. Wilkinson, 7 years ago, made a statement about FAIR, and essentially he has there one sentence which is more or less the starting point for what we call FDOs. This necessitates machines to be capable of autonomously and appropriately acting when faced with the wide range of types, formats, access mechanisms, protocols, and so on, that will be encountered during their self-guided exploration of the global data ecosystem. The question is, this is a great goal. The question is how to implement such a capability for machines. And the question, of course, is what are the elements? Essentially, you can see it here. Those are the elements in the global data ecosystem. But there are also services needed to make this actually happen. One verb here was what was types. Types are about the structure and the encoding of FDOs. And and this is a very, very general expression here. Remember the properties of MIME types. Essentially, they are human readable descriptions and internal encodings. These digital objects may have a quite complex internal structure. And all this is described on the reference level as a suffix in this case. So essentially, if you have a name of a digital object which ends with PDF, you know that this has a certain structure, and the services can use this knowledge to directly open some viewer or some other kind of possible changement and operation on this object. The problem is MIME types often describe structure, format, and encoding altogether. So there are different dimensions which are mixed together and build one certain MIME type. And this has the problem, of course, that if one of these dimensions is changed somehow in a newer version, this essentially leads to another necessary service. And we see this in these operations we have on different of these MIME types, that they have to adapt, they have to understand these. They have to know from getting the data how to interpret this new structure and so on. Another problem is they have a long endorsement process, of course, and then there is often more that we want to know than that. For example, if you have tables, a table like something with a MIME types as a comma-separated value table, then you need to know the separator, the column mapping, column encoding, and so on, because the applications of tables are often on selected columns. So you know in advance that a certain, you want to know about a certain variable, and that is you don't know previously in which column this is. And it would be good to have this also in advance when you get the column, the table. The question is how to make type information machine readable. And this goes beyond, of course, that what human readability means, because we can interpret things, put them into context, and all this is usually for machines unavailable. The knowledge has to be at the reference level again. This is something which is also for humans good, but for machines essential. And this is, as said, a typical possibility you have with MIME types. The idea is to provide such generalized type information as an attribute of an FDO. MIME types could be then a part of it, but as said, other informations are also valuable. We need a general approach for all PIDs, FDOs that answers what can be expected. So at the reference level here, we see the PID, and we expect from the PID that there is a way to understand what are the attributes and what is the content of the attributes. This goes at the level of the PID itself. So we need to know what the structure of the PID, or later we will say the FDO record. This can be a PID, it could be also something different. But here at this point, we would say that the PID, the reference level, is presenting what's going on with this digital object, and also has a certain structure therefore. And then a particular type which has a structure again has to be understood by the machine as well. The type information needs to be structured, and the structure needs to be disclosed and readable for machines. That's essentially the bottom line of this slide. And the question then is, what is needed to describe this structure and to make it available for machines? There is a universal pattern for disclosing structures and also substructures. And we know that from XML, for instance, there usually keys are used. They point to structures and substructures, and these keys are in namespaces to avoid name conflicts between these keys. Similar in LD, linked data, there we don't have namespaces, they call it context, but essentially this is the same concept. And for the FDO framework, again, here we suggest namespaces as well. We call them registries because behind these namespaces, which is also the case for XML often and LD, often they are explained. There is a machine and a database behind it that says what exactly is meant by certain keys. This general structure leads to a hierarchy of information pairs. So one can have in this case, a JSON-like object with a key, the structure, and pointing to the structure and the content, which is essentially in line with that what the structure is expecting. And this can be hierarchized, of course. And we know all this, this in objects as well, in XML, as in JSON, and in other languages as well. Again, here the structure is often given and referenced by a key, and the reference describes the value space. And this pattern essentially also should be used for the whole information structure that is needed for machines for FDOs. So the universal pattern, each structure of a key is described in a registry. The key points to that description by reference. The value complies to the referred description. And there is a certain strategy to avoid overloading the reference itself. If this value is complex, then it can be again given as a reference. So the value can be a value itself, but it also can be a reference which then leads to the value. What we here describe an interoperable type registry landscape. So these registries shouldn't be alone. They should have a generalized structure and a certain way to reuse definitions in one registry, in another registry, and so on. They described, of course, as said, structures for value spaces, and these descriptions can be, we know that from other languages like JSON, often the value spaces are described by schemas. These registries are in a certain way generalized schemas, so they can lead to JSON, XML, or whatever schema for a certain metadata description. They are again key value pairs, and these descriptions itself are described as in a way as it is for the data object itself. Actually, these descriptions become FDOs at the end. So they are quite similar to that what we expect also for digital objects. We call these structure descriptions type definitions, and a type is not a type definition. A type definition is can be a type. Essentially, the type is a pair. It's the type definition as a reference, the key and the value for this type definition. That's the general pattern again. And of course, we have then a bootstrapping problem because the whole system should work like this. We also need to know to determine that a type is a type. The machine has to understand that. So we are not looking as a human at that. We are looking with the eyes of a machine, and the machine has to distinguish other things from a certain type definition, and this is the problem we are facing here, and this has to be also defined. So we need a type definition, and this also has to be registers in a type registry. In the former RDA working group of about data type registries, there was a data model developed, and this has a lot of different aspects. There's an identifier, a name, readable description. There's provenance information, related standards, expected uses, and then there is a chapter representation and semantics and a chapter about properties expected, and those are quite interesting because in the representation and semantics chapter 1, these are essentially used to describe the hierarchy between types. The representation essentially is used to describe which kind of substructure is there, whether it's an object, an array, whether it's a set-wise conglomeration, and so on. And the properties are then used to describe the depending types in this case. And this actually can be boiled down to a very minimal set of key value pairs, and those are essentially the name, the identifier, the representation and properties, and the name could be for human readability something which is used to make a certain semantical connotation. Sorry. Next step is then profiles, because these type attributes in a FDO record, which could be a PID, for instance, has to be described. So the machine needs to know what it can expect when the FDO record is used. And these are, again, very similar to that what a type definition is to some extent. So at least they can be described in a similar way. The reason for this is essentially that these digital objects usually are in the pattern different over the communities, over the use cases, and so on. So one can expect that there is a need for different set of attributes, and this has to be disclosed to the machine such that it can be understood what information will be available for a certain digital object. These profiles describe which attributes can be expected, and the profile definition, of course, has to be somewhere provided, similar as the type definition, and will be registered in so-called profile registries. And again, these profiles contain key value pairs. Here, these keys are not necessarily type definitions anymore. They more or less describe classes of attributes, and the way we describe that, we have decided to call them genre. Again, their values are defined by the structure given in these genre. We also need a kind of obligation parameter. It might be that certain attributes are only optional. Obviously, mandatory attributes are mandatory. They have to be provided, and a machine can expect that there is a value for them. How to implement this? The generic schema is store a type definition in a DTR. Type instances are key value pairs. They store such descriptions as type instances. This again can be, as said, be directly in the FDO record, which could be the PID, but also it can be a external storage, another registry or a repository that stores this information. And the type ID in a PID stores the reference to the type definition and the type instance as a key value pair. If you have it directly in the FDO record, in this case, the PID. Then, as said, we need these profiles, and the pattern here is very similar. And at the end, the type definitions and type instances itself have to be FDOs again. So their description and their reference has to be registered. They have a certain FDO record and so on. This all is especially interesting because this way we can guarantee a reusability of types if this definition structure is the same, standardized over registries, and therefore we would be able to reuse types in profiles as well as types types on other communities, in other type registries, for instance. How does it look like in a more or less dependency between certain services and certain components? So we have the FDO, which is something which is stored in a repository and has a PID which refers to this FDO. And then this PID in this case would be the the element which has all the information. In this case, it has attributes, and these attributes are certain key value pairs, type A with the content, and so on. And this agglomeration of types is described in a profile, which again is registered in a profile registry. The type definitions are registered in type registries, and all of them are FDOs by themselves, so they all have again PIDs which are given by a certain PID service. So this is a very very simple and abstract view, but the problem here is that it's mixed in certain ways. So we have real services, but also we have more or less abstract concepts like profiles or types described in the same way and on the same level. And we decided to make another view on that and expand it actually. And this is a more or less completely conceptual view. So there is not directly involved any any working component. There are some registries and repositories described, but essentially as here you only see concepts. Oops, for some reason it seems that you don't see my slide. I'm not sure what's going on. I'm doing nothing on my screen here, but I see.
Sorry, it's my fault. It's my fault.
Oh, okay. Okay. Now I understand. It's not me who is managing the slides. I wasn't aware of that. Sorry. Okay. So yeah, this is the correct slide for what I said. This seems to be very complex. Actually, there are certain areas which should be looked at separately. So here we have in the next slide, for instance, the area where you see the old view, which is already a very old view in RDA, where essentially a digital object has a PID, has metadata, and has a bit sequence, and this metadata has a schema and a structure, and this structure defines the bit sequence. So this was one of the outcomes of the Foundation in Terminology working group of RDA. And this view is part of this diagram. Again, in the next slide, there you also have what I've depicted as essentially these storage of attribute definition, type definitions. They were called before. Now I would tend to say more or less that we have attributes here, and the profiles which are describing the FDO record are also stored in a profile registry. We have schemas for attributes as well as for schema, and these are meta descriptions of how to describe attributes and how to describe profiles, and they are stored in another repository to be referable for the machines. You see in this diagram essentially three colors. Those are the greens, which are clearly in the realm of the FDO forum. They have to decide what is defined there. And then there are the red ones, which are clearly defined inside the communities. Those are, of course, the metadata, the bit sequence, and so on. And to some extent, obviously, also the FDO itself. But here again, as the configuration and the description of the FDO record partly depends on standardizations from FDO. We have colored them blue as describing it could be defined by community as well as by the FDO forum itself. So I think that's all I have, and I'm open for questions and discussion.
Thanks, Ulrich, and sorry for other audience. The background maybe it's a little dark, but I will share it, share slides on the website, so maybe you can find it in future. And thanks, Ulrich. Now it's open for discussion. Any questions or comments to the presentation? And maybe I think via the open platforms, if you have questions, you can unmute yourself, and that's great. Is there any questions at the chat box?
Carlo, you just have to jump in.
Hi, Mark.
Yes, I have a question.
There you go. Yeah, Carlo has his hand up.
Yes, two questions actually. The first is about the definition of the difference between profile and type. Because if I go back to object-oriented programming, a type is defined by the set of attributes and the function of a class. So I'm a bit confused at saying that the profile is a set of attributes. So I don't see what is the type. I think it's a bit, there is some overlap in these two notions. And the other question is about registries, because you say that we will have a type for registries, but types are digital objects. So how can we differ the digital object which has type from the other ones? And why don't we use the same repositories for all the digital objects?
Essentially, I'll come to the second question first. Using the same repository for everything would probably, in principle, it's possible, of course. One can have everything in one repository. It would mean that the descriptions have to be separated because they have different structures. They have to be separated by their structure. But yeah, it could be done. Essentially, the difference is at a governance level here, because communities will decide, will not directly and obviously describe their types for themselves, or their type definitions, their attributes for themselves, but also they might want to have a certain set of attributes used, and that means that those which are describing and defining types usually would use their repositories for for this, and then the communities would pick up these attributes for their use cases and describe the key value pairs they need depending on these types. And this set of attributes, which I said would be the profile here, would be then defined at a community level. So there are different groups acting, and that usually leads to different governance structures. So this is the reason why we would at least see the possibility to separate these things. It's as I said, it's not necessarily the case that it's separated, but for governance reasons, we would have this option. And the first question about the difference between profiles and types, essentially, this, as said, the syntactical structure is almost the same. The types are more variable to some extent, so they can have they can implement different syntactical structures, or more rich syntactical structures than these profiles, because the profiles are essentially a enumeration of expected attributes. And but this is actually the only difference. So one could say that a profile is nothing else than a type on a higher level. So it's true, and this is actually a discussion what we are currently having in the FDO forum about this question, whether we should rename things and look into the direction to say that a profile is the type, and everything else behind that are attributes of this type.
Thanks. Only one more question. I saw maybe Mark has a question.
No, I didn't have a question. I just was calling attention to Carlo has hand up.
Sorry.
But thanks.
Actually, I have some more questions, but due to the time, let's hand it over to Dr. Luo. Well, thank you again. Thanks for your reach, and thank you to give this presentation at such an early morning. Thank you.
Yeah, you're welcome. Thanks.
Since Dr. Luo has some updates to his presentation, so I will stop sharing and give it to Dr. Luo.
Okay. Sorry, I can't share my screen because I'm not a speaker, I think. Can you hear me?
I can hear you. But,
yeah.
could you send it? Maybe you can send it to me and I will share it for you.
Okay. I can share my screen now. Okay. So can you see my slides?
Yes, I can say it.
Okay, so I will start my introduction. So everyone, I'm glad to share my our work about the Internet of Data. So today my report title is the Internet of Data and Infrastructure for Unified Digital Space. So first, what's the Internet of Data? Here is an example about the United States Department of Defense. So don't worry, all these contents are public and open. You can get it from this link, okay? So in 2020, in 2020, the United States released its data strategy. They hope to involve its combat system from information to intelligence. To this end, the United States needs to transform the existing information-based network space into the intelligence-based digital space. So in its data strategy, they standardize the data sharing, access, discovery, and exchange of data in a protocol way. It is hoped they hope to realize the data availability. They hope to realize the data, make the data available, visible, and accessible, understandable, linkable, and interoperable, and trustworthy. So based on this strategy, DOT needs to build the infrastructure of the digital space on the existing information network infrastructure. So you can treat it as the internet, which is the defense info system network. Based on this DISN, they want to build another infrastructure, which is the .info network, which is the DODing, and it is a kind of Internet of Data. So from a technical point of view, the Internet of Data, it is a virtual layer built on the internet, actually. Today, a large number of smart devices are distributed in the internet, and these devices and applications generate data all the time. At the same time, a large number of applications want to use this data. So the core value of the Internet of Data is data scheduling. That is matching data providers and the data users. However, the internet is essentially a network of machines. The internet uses the host to represent machines, assign an identifier to each machine, that is the IP address, and specifies the communication protocol between these machines, that is the TCP protocol. Based on this system, the internet realizes the interconnection between machines and machines. However, this network is a network of machines, not suitable for the scheduling of data. Therefore, there are many approaches to realize the data sharing, or we call data scheduling on the internet. Typically, is the data platform or data centers. These platforms and data centers aggregate data and provide external data services based on the physical aggregation of the data. However, this platform-based approach can only realize the data scheduling within the platform, and the data cannot be shared between the data platforms. Therefore, the digital space based on these platforms are actually a fragment digital space. The Internet of Data regards data as an independent element out of the any machines and regulate the data in a standardized way. thereby realizing the internet scale data scheduling and form an integrated digital space. So the red layer is the internet of the data. So the key to the internet of data is how to unify abstract data. The digital object architecture, which is the DOA proposed by the inventor of the internet, Readable, it is a feasible way to abstract data. The DOA can be divided into 3 parts: a model, 3 system components, and 2 protocols. A model refers to the digital object model. DOA abstracts data resources based on the digital object model to share the data, the difference between data. A digital object can be divided into 3 parts, which is the identifier, metadata, and the data entity. These three components are managed by the 3 systems separately, which is the identifier resolution system, which is responsible for managing the identifier of this object and provide the resolution service of this object. The second is the DO registry, which is responsible for managing the metadata of this object and provide the search find service of this object. And the last is the DO repository. The DO repository manages the actual data, which is the data entity, and provide the data access services of the digital objects. So the 2 protocols refers to the IRP protocol and the DOIP. The IRP protocol is a standard protocol for interaction with the identifier resolution system, while the DOIP protocol is a standard protocol for the repository and registry. The most widely used DOA identifier resolution system is the handle system. Currently, 18 root nodes have been established in 20 countries around the world, support international scale digital object applications. One of the most typical applications is the DOI system. Every one of us should be familiar with this DOI system. Each of our published paper will be assigned a globally unique identifier to permanently identify this paper. This system is built on the handle system, which is use the DOA architecture. The root node of the DOI system is actually owned by the MPA of the United Kingdom. The DOI system currently supports more than 215 million digital objects. Based on the DOA, we can realize the interconnection of data under the same standard. For example, the 2 different IRP files in the picture, left and right, are modeled with a digital object model, which is represented as 3 parts: identifier, metadata, and the data entity. Then, the 3 systems and the 2 protocols of DOA can support the interconnection and the interoperability of the 3 elements. Based on this, we can realize the Internet of Data. It is worth to mention that the Internet of Data is not a substitute for the Internet, but a virtual network built upon the Internet. Based on the DOA, we can achieve interoperability between the data resources and in a standard way, but the Internet of Data still faces another huge changes. how to efficiently match the data demands and the supply at a scale of the internet. We provide an architecture to solve this problem. In our architecture, we implement data scheduling in the Internet of Data through a layered approach. Overall, our architecture is divided in two planes, the data plane and the control plane. The lower plane is the data plane of the Internet of the Data, and we implement this plane based on the DOA. The digital object model is used to abstract data tasks and the data resources of the internet to make a uniform representation of all the data jobs and the data resources. On this basis, we also propose a control plane, which is mainly responsible for the realization of digital object scheduling. To this end, we propose the concept of data pragmatics, which is a formal way to describe how data is used by which data jobs and in what way. In the control plan, we describe the pragmatics of digital objects based on their identifier, metadata, and the standardized operations described in the DYP protocol of DOA. Using this, which describe which data task in what way and which data source is used. Data pragmatics are the core of data scheduling. The independence of the data pragmatics allows the control plane to focus on the data scheduling without caring about other things that have nothing to do with the data scheduling, such as the data types, data formats, and so on. Based on the control plane, the application program of the application plan can realize the scheduling of these objects by programming the control plane, and then control the data task and the data resources in the internet. Similar to the internet, obviously, there's no trust center in the internet of data. In order to ensure ensure trust of data scheduling, we implemented the distributed ledger in the control plane, and all the data scheduling will be decentralized. Consensus decentralized in the control plane. This enables the decentralized data scheduling. We started to experiment and the verification of this of our technical system in 2018, and verified the feasibility of the technology theory and standard. In the internet environment, 500 nodes can achieve a data scheduling efficiency of over 1 million transactions per second. Since 2019, we have started to promote digital the Internet of Data in China, both in terms of fields and in terms of domains and territories. In the domains, we implement the Internet of Data based on the national research and develop project, and the territories we implement our systems in some office and in some governments, and now we have provided more than 10 provinces and dozens of cities of the of our software. Finally, to make a brief summary, the Internet of Data, like the Internet, must be an international, open source, and shared technology system. Only through the joint construction and the common governance can realize the true value of the Internet of Data. Just like the TCP/IP protocol of the Internet, the core of the Internet of Data is also the protocols, which is the DOIP and the IRP protocol. And based on the protocol, we can share our data and make data scheduling, interconnection, and interoperability. We also provide our open source standard protocol implementations, as well as several infrastructure software for building the Internet of Data, which are also open source. Here is our link, our software links, and we use the Mulan license, which is more friendly than the Apache. So this is all my introduction. Any questions?
Thanks, Dr. Thanks. Many thanks. And any comments or any questions? I have one question. I noticed that in your picture, you notice you are collaborated with your team collaborated with Caldra. Can you give some details about this?
Yeah. Okay. So we can see this picture. Caldra is actually infrastructure software based on the DOA. They also implement the DOIP protocols, and it's open source. You can see. So now we have to test the interoperability between our software and the Caldra software, and it is you can use our client to access the Caldra repository, and also you can use the Caldra client to access our repository. So it's basically the same function of different implementations.
Thank you very much. So if there's there are no more questions, so let's thank you again. Then please stop your sharing. Let's move on. Let's hand it to.
Okay, sorry.
Dimitris, now it's your stage. Oh, I can see your screen. It's perfect.
Hello, everyone. Thank you very much. I hope you can hear me and see the screen.
Yes.
Thank you. Thank you very much, Lori, and the organizers for extending the invitation. I'm very happy to be here. And this presentation will be a bit different in the sense that I will try to give an example of a large-scale implementation of FDOs in a specific domain, and specifically in the domain of natural science collections in Europe. This is basically all the organizations that probably you knew when you were younger or you brought your children that hold natural science collections, the museums of natural history around the world, and the people behind it that are responsible for describing life on Earth. So I will actually start the presentation by trying to give a bit of an example on what is the challenge that the FDOs are trying to resolve in the European, at least, landscape. And I will start with this unorthodox object in relation to natural history, because this is the physical object that for many years was used to basically define the standard for the unit of measure of the kilogram. So it was used and it was positioned in a few places around the world, but basically helped us define what the mass of 1 kilogram was. And as you probably know, over the last few years, our colleagues have tried to basically digitize that physical object into its, from a physical object into its digital surrogate. And what we have done is basically translated that physical object into the Planck's constant that now has been used to define the unit of measure for 1 kilogram. Similarly, this is a physical object that lies comfortably in one of our collections in Europe and specifically in London. This object is basically similarly the standard of measure for what it constitutes a species, and specifically the species Apis mellifera, which is the European honeybee. So a type specimen, as we call it, is equal to a standard. And in natural science collections, we have approximately 3.5 billion objects across the world that represent 10 million of those type specimens that help us define approximately the 2 million known species, biological species of this planet. So you do understand that we have a huge challenge in the context of digitizing our standards, our specimens that goes beyond, way beyond the digitization of one object. And of course, the reason we want to do this is because we know still very little about life on this planet. We know that we have described approximately only 10% of life on Earth. And we still have to describe approximately 18 to 22 million species on this planet so that we are still at least know what we have to protect or what we are losing every year from biodiversity decline. The natural science collections around the world play a substantial role in this because together they actually form our understanding of biological, I would say also the geological diversity of this planet. I'm trying to advance my slide. And my PowerPoint just crashed. Oh, here it is. So to do this, we're actually trying to access the collection. So access to the collections has been essential for all the scientists for hundreds of years to be able to describe all of those species. And of course, physical access is slow, expensive, inefficient, to some extent limited. Only in Europe and before the corona pandemic, we had approximately 25,000 researchers accessing annual European collections, moving from one country to another, or we were shipping around 800,000 specimens every year from one place to another for exactly the same reason. But why do scientists want to access the collections? What do they get out of this? Basically, a physical object is nothing else but a container of a lot of information that the scientists are trying to extract. Genomic data, biochemical data, morphological data, taxonomic, species interactions data, and ecological information. And in that sense, we have now a new initiative in Europe that is trying to basically lower the threshold of access across all of those collections. DISCO, the Distributed System of Scientific Collections, brings together 170 national facilities, i.e. national history museums, national science collections, and collection holding universities across 23 countries to basically transform them into one single European collections of scientific assets. And we're doing this with developing common collection development strategies, building economies of scope and scale, and monitoring the impact of our collections and by documenting the return of investment. I'm also trying to advance my slide again. Bear with me for 1 second. Something is wrong with my PowerPoint. I apologize. Essentially, what we are trying to do in our attempt to digitize our in the context of DISCO is move from a model where we actually moving specimens and people from one place to another to be able to access those collections in a model where we transform the physical object into its, I'm really sorry, my PowerPoint is not, something is wrong.
Should I share the slides instead?
Sorry, Laurie, can you say this again?
Do you need, could you still share your screen? Maybe I can share the screen instead of you.
Yeah, okay, maybe I will stop sharing for a bit and see if you could do this for me instead. I'm really sorry for the technical issue. Yeah, my PowerPoint has completely crashed. Thank you very much, Laura. If you can move to yeah, the next
Is that right?
slide, the next slide, please. Yeah, thank you very much. So what we're trying to do is move from the current slow model into an integrated model where we provide wide access, lower the cost, and for accessing all of this information. And the only mechanism to do this is by basically trying to replicate the research capabilities that the physical object is giving into the virtual world, into the cyberspace. And that must mean that basically we have to unite all of that information that scientists have been extracting out of each one individual object back into the digital surrogate of the object. And that includes its genomic, chemical, geographical, morphological, and all the rest of the information. Next slide, please. I'll try to move faster. Next slide, please. I think this was, I changed the order before. Next one. Yeah, the next one. I think I explained this one. And next. So here we are. So that process of digitization for the natural science collections goes way beyond what we call imaging or photography. It's basically a mechanism through which we need to, as I said, transform the physical object into its digital surrogate. And this is where the concept of these electric butterflies come in. Those digital surrogates of the physical object must be actionable knowledge units. So basically they have to contain all the information that is required for the scientists to be able to perform the same amount of science that they would have done if they had access to the physical object. And basically what we create is a fair digital object as the digital twin of the physical object. And this is exactly the conceptual application of the fair digital object within this domain. Next slide, please. The way we're doing this is basically quite simple, and we follow, of course, the work being done in the Fair Digital Object Forum and across the world in relation to the fair digital objects. Basically, we have a structured data that we apply a schema for it to make it more machine readable. We start putting the semantics behind it in terms of the disciplinary metadata and the vocabulary is used to create interpretable elements, basically making it machine interpretable. And then, of course, we define operations and capabilities upon these objects to make it machine actionable. So in the very basic structure of the digital specimen, we will call it now that digital object, a digital specimen. Basically, you have a structure, a domain-specific set of vocabularies, the semantics around this, and a set of operation capabilities that you can perform on that digital specimen. And all of that has been basically significantly based on the work being done, not only in the Fair Digital Objects Forum, but also within other domains, and especially within RDA, with the results of the different interest and working groups over the year. We have published a paper around this in the definition of the architecture of DISCO. Next slide, please. And if we want to see basically the anatomy of that digital extended specimen, which is a digital object, basically, of course, it has a persistent handle, which we have decided that this should be a DOI. It includes authoritative information about the specimen. It also includes supplementary information derived from the specimen. So one interesting idea is how that digital specimen basically can act as a platform for AI and other machine activities that enhance and augment the information within the object itself. We have associated information related to the specimen, and of course we have some media that is very important to document that specimen on cyberspace. Next slide, please. So when we're talking about the integrated data space for at least natural science collections, we're not really talking about the large internet data space for collections, but also a meaningful and self-interpretable data space. Transforming the digital entities into meaningful entities is a process that requires a lot more than just digitization or imaging. We need to link persistently data, of course, with the metadata. We need to enable all the data objects to become self-interpretable, actionable, and at the end of the road, trusted for the purpose of their use entities. And of course, enable, and I think this is extremely important, at least in our domain, the curation and annotation of those digital objects, of those digital specimens, to be performed across repositories and permanently allow those annotations to be linked back to the object itself, to the digital object itself. Next slide, please. And for me, this is an essential, fundamental shift from the way we do science that actually the Fair Digital Objects are enabling our domain, that allows us to gradually move away from the limitations that the physical scientific curation of our objects impose, that have to do with geographic boundaries and a lack of ability for people to access, but also the decline in the expertise we see within our institutions linked to the collections, and bring that curatorial space into the commons. Allow people to be able across the world to perform that scientific curation without the boundaries of the physical objects. So we're gradually moving into a community curation model where all of these annotations, where all of these scientific activities upon the specimens are performed not on the physical object, but on their digital surrogates, on their digital twins, and where all of these annotations, all of those curations are staying together with the digital twin, with the digital object. And of course, that means that we are able to actually document better the provenance and the transactions on all of those digital specimens, be more responsive to urgent need, and at the end of the day, be more efficient and able to massively accelerate biodiversity discovery, going back to what I said before, that we still have a long way until we're able to describe life on this planet. Final slide, Laurie. So as we move from volume to volume, I think in this process, what I call creating the electric butterflies goes way beyond digitization of our collections. It requires a fundamental shift in the way we enable science to interpret and interact with the digital object. The concept of the Fair Digital Object, at least for the domain of natural science collections in Europe, has been fundamental in actually building that architecture, that data architecture that enables us to allow our scientists, enables our scientists to perform and accelerate science at the rate and level we want them to. Thank you very much, and apologies for the technical issues. Shall I move to the next, Laurie?
Yes, sure. Thank you.
I'm mindful of the time. So, This part of the presentation is mostly to announce to the International Data Week the upcoming first international conference on fair digital objects. This is the first conference on fair digital object that is organized. Next slide, please. Well, I think I have to say a few words about the Fair Digital Objects Forum, a couple of slides, because the Fair Digital Object Forum is the driver and the organizer of that event. I would like to say that basically the working towards substantiate the vision as has been articulated by George Strawn, that basically describes how we move away from the next step from the internet revolution into the fair revolution, and how we move gradually away from the one computer, many databases situation that we all experience today into the one computer, one database vision of the future. And the fair digital objects are the building block of this global integrated future data space. So the next slide. The Fair Digital Object Forum, this is the anatomy of the FDO, but I think we can skip this one because the two speakers before me actually explained this much better than this slide does. So let's move to the next slide. The Fair Digital Objects Forum is a neutral place, and I would like to highlight that also from the point of view of a technology agnostic space, where policy, research, and technology experts can meet to bind and exchange knowledge on all relevant aspects of the FDOs. The FDO Forum does not work in isolation. It basically acts at the intersection of big data organizations, and of course, RDA, GoFer, GoData, WDS, I would add here, and all the work that has been done in these organizations and in our communities. And of course, the Digital Object Fabric is one of them, interest group, but also the implementation network within the GoFer community. Next slide, please. Our work in the Fair Digital Objects Forum is organized in different working groups. Actually, you heard previously in this session, Ulrich talking about some of the work within the basic infrastructure group, working group that you see here in the slide. Currently, we have 5 working groups that are progressing with different aspects of the definition, framework, and implementation capabilities of FDOs globally. Next slide, please. So the premise on why we needed an international conference on fair digital objects. Multiple community efforts, of course, again, RDA, GoData, GoFer, the Fair Digital Object Forum. There is a very diverse landscape of activities right now, not only in terms of the communities, but also geographically across the world, that talk and implement and help define further the concept of the fair digital objects. We need, of course, convergence and agreement upon certain parameters and attributes of those FDOs. And I think it's very, very important that we do this together and collectively, not only, of course, in the context of one conference, but the conference can become a milestone event for this kind of a convergence and agreement. We need to have the opportunity to showcase implementations of these FDOs and actually be trusted by the entire world that FDOs can provide solutions for certain challenges. We need to have wide communication about what they are and what they can do. And of course, we need to engage policy so that we can create the enabling environment of the future for the mass scale implementation of FDOs. So this is the premise for why we wanted to organize a conference like this. Next slide, please. The first international conference on fair digital objects is taking place in Leiden, the Netherlands, between the 26th and the 28th October 2022. It's organized mainly by the Fair Digital Objects Forum and is part, and we're very happy about this, of the European City of Science Leiden 2022 activities. Every year, one city in Europe becomes the European City of Science with a lot of activities. This year is Leiden. And there are a lot of scientific activities taking place across the year, and the conference is part of the portfolio of those activities for 2022. And it is hosted by Naturalis Biodiversity Center. Naturalis is an organization that is driving forward also the research infrastructure DISCO that I described before. we do feel that we have the responsibility also to give back to the community of the FDOs, as we have been benefiting from that substantially in the context of the research infrastructure development. Next slide, please. The FDO conference has four main goals to present and discuss the anatomies of FDOs, to showcase FDO-based studies and implementation, to act as a forum for developing FDO-based approaches and propose solutions to facilitate global adoption of FDOs. At the end of the conference, we're very happy to say that we will be able to issue the Leiden Declaration, a mainly policy document that will be handed over to policymakers across Europe in an attempt to basically kickstart that discussion on how we need policymakers to start thinking about enabling environments for the large-scale implementation of FDOs at the national, but also at international level. Next slide, please. These are the themes of the conference and a very high-level structure of the conference. It's being split across three themes: science, technology, and policy. As I said, it runs across 2.5 days from the 26th and 28th. And of course, you will see that mostly the policy activities are taking place on the last day, as we expect to have also representatives from different governments present at that point. But of course, we also have a strong emphasis on the scientific, i.e. the implementation opportunities of FDO in science, and of course the technological aspect of the FDO. So if you are involved in either facet of these FDOs, you're more than invited to join us in Leiden in October and be part of the conference. Next slide, please. Registrations are open. You can go to fdo2022.org, and of course we have a abstract call for abstract open. The deadline is 10th of July, so there are still 19 days to submit your abstracts. All the abstracts will be properly published in a journal, the Research Ideas and Outcomes journal, and there are details on the website on how you can initiate your abstract and how you can submit it through the publisher. We accept abstracts across all the three themes of the FDOs: science, technology, and policy. Next slide, please. So last slide. Thank you very much for listening. We're super happy to be able to run this conference in October. Please do register. Please join us in Leiden in October 2022. More information at fdo2022.org. Thank you very much.
Thanks, Dimitris. It's fantastic, but there's only 1 minute left for this session, so maybe no more question for you. So, maybe we can talk about this. I'll talk about these questions in the future. Monthly sharing of at the IG. And this is an advertisement for our IG, the Fair Digital Objects Fabric. We have a monthly meeting, mainly about project sharing on every fourth Thursday each month, so we can meet there. And at last, thank you all. Thanks for all the speakers here. Ulrich, Dimitris, and Charan, and see you next time. Oh, don't forget to thanks to all the plenary organizers.
Sorry, do you want to have?
Well, I had a question, but I don't know if there is still time and Dimitris is still online.
If we are not, the meeting is still going on. Maybe
Okay.
We have time.
Okay, so hi Dimitris. Normally I walk over to the building, but now I'm in Seoul. So thank you for your talk. I have two questions. First, a practical one. Can you send the slides of the conference to me ASAP, because I can show them in a plenary session later on to plug the meeting again? That's one.
Yeah, we'll do, of course, Barend. I will
Okay.
send them to you now.
But
yeah.
the question I would really ask in terms of FDOs, what you call the digital representation or digital counterpart, we have also branded a fair digital twin. Huh? And what we struggle with, and I see that also with you, if we do this for example, a mental construct like pancreatic cancer, maybe comparable to a species in your case, and then you have the individual biopsies, you know, of pancreatic cancers that we have in the hospital. So one digital object refers to a resource that is actually a physical resource, an object in a collection in your case, or a biobank. And the other fair digital object refers to what we call a type or a mental construct, which is not even existing as a physical thing, like a species. It's a mental construct. Do you make a specific metadata reference to that and say what is the nature of the resource we are pointing to? Can you say a few words about it?
Yeah, absolutely. And we are, that's a very good question, Barend. Thank you very much. And indeed, this is absolutely necessary and can be done on 2 different levels. The object itself can define what actually it represents. It can represent a mutable or an immutable object, of course, and how it's linked to, as you said, how it's defined in itself. But also I would point back to the need actually for data type registries in the future, where this kind of information is independent from our need to actually resolve the handle of a digital object before we actually understand what the digital object represents. And for our community, this has been a very long discussion on whether a fair digital object or a digital twin represents an immutable version of a specimen, for instance, or whether it represents the concept of a specimen or the concept of a species, as you very nicely put. And I think this is, we're still struggling with this, and I think there are different ways of implementing this, but I think this is a very, very important topic that we need to be very mindful of. Currently, yes, our metadata schema actually describe what that object is in a way that the community can understand better what it represents. But I think we need to do this across communities and be able to define data type registers in the future that are interpretable by machines and people outside of communities and across communities.
Thanks.
And I'll send you the slides. Thank you very much.
And thank you again. And I'm very sorry for all the audience in Seoul. And other questions, maybe we still have some time. If there are no,
I think we are done in this room.
Thank you. And if we have no more questions, and maybe we will close this session. And please don't forget to sign the collaborative notes, and I will send the slides and the recording to all of you after this session, if the recording is ready. And goodbye, everyone.